Welcome to episode 63 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Today's episode is all about the statistician's favorite, the R programming language. Amy, whenever I say R, I can almost hear statisticians cheering in the background.
Absolutely. R has been the go-to language for statisticians and data analysts for decades. But it's not just academic. It's very much alive in the business world, too. So, Jonas, why do you think R has held such a special place in the data toolkit?
Well, at its core, R was designed specifically for statistics and data analysis. Unlike some programming languages that try to be generalists, R began as a language to help statisticians and researchers handle complex data and their computations quickly. It's unique because it's both a programming language and an environment tailored for statistics.
That specificity really shows in its abilities. In my consulting work, I often see companies with messy, real-world data needing deep statistical analysis to understand trends, assess risks, or build predictive models. R's vast package ecosystem, those pre-built tools for everything from regression to machine learning, makes crunching numbers and exploring data more manageable.
Exactly. And to give some background, R was created back in the mid-1990s as an open-source alternative to the proprietary software S. The open-source aspect helped it spread quickly among academics, statisticians, and eventually practitioners. Its syntax focuses on vectors and matrices, which makes manipulating datasets intuitive for statistical modeling.
For sure. And in industries like healthcare, I've seen R used extensively for clinical trials and genomics. One example that sticks with me is a hospital network that used R to analyze patient outcomes and predict potential complications. They integrated R scripts into their workflow to detect patterns in treatment responses, which saved lives and improved care efficiency.
That's a great example. R's statistical packages allow users to apply methods like hypothesis testing, time series analysis, or clustering, all of which are critical in healthcare data. Another strength is that R's graphical capabilities let you build detailed visualizations, plots, charts, heat maps to help decision-makers quickly grasp complex results.
Visualization is a game changer. I remember working with a retail company struggling to forecast inventory demands. They had tons of sales data, but didn't know how to present it in a way that the store managers could act on. Using R's ggplot2 package, we created easy-to-understand visuals that showed demand fluctuations over time by region and product category. Suddenly, their decision-making became a lot sharper.
ggplot2 is indeed one of R's crown jewels. It's a visualization system based on the grammar of graphics, which lets users build complex plots step by step. That combination of flexibility and power appeals to both statisticians and business analysts alike.
I love that about R. It speaks to both deep data experts and to business users who want actionable insights. But Jonas, there's always the question, with Python growing so rapidly in data science, where does R fit into today's world?
A good point. Python has become a dominant language in AI and machine learning, largely because of its versatility and extensive libraries. However, R remains unmatched in specialized statistical analysis and rapid prototyping of statistical models. Sometimes choosing between R and Python comes down to the problem at hand and the team's skill set. For projects heavy on statistics, R can be more straightforward.
From a consultant's perspective, I advise companies to be pragmatic. If you need quick exploratory data analysis and powerful stats routines, R often saves time. On the other hand, if the goal is to build scalable AI systems or integrate with production applications, Python usually wins. Yet, many businesses use both because they complement each other.
That's right. And another interesting feature of R is R Markdown, which allows data scientists to combine code, output, and narrative in one document. This mix of analysis and storytelling supports reproducible research and makes it easier to share results with stakeholders.
Reproducibility is huge in business. When working with financial institutions, for example, regulators want to understand exactly how models are built and validated. R Markdown reports help teams demonstrate transparency. It reduces risks around audit compliance and builds trust internally.
We didn't touch on it yet, but the R community is also a powerful asset. They contribute thousands of packages on CRAN, the comprehensive R archive network, covering everything from econometrics to bioinformatics. That means someone likely already wrote the solution you need.
And that open source spirit means new innovations get shared fast. I recently saw a car manufacturer use R for analyzing sensor data and vehicle health monitoring. They developed custom algorithms in R to predict maintenance needs, minimizing downtime and boosting customer satisfaction.
That's a perfect illustration of how R's statistical roots adapt to modern data contexts. Sometimes it's about classical statistics, sometimes cutting-edge data science, all wrapped in one environment.
Still, for newcomers, R can feel intimidating. The syntax is different from typical programming languages, and the learning curve is real. How would you suggest managers approach that when introducing R in their teams?
I'd say start with the problem, not the tool. If your team needs statistical analysis, invest time in learning R's basics and leverage its resources. Online tutorials, workshops, and user forums are excellent. And remember, you don't need to be a programmer to benefit from R. Many graphical user interfaces, like RStudio, make it approachable for analysts and even managers.
That's important. I've seen organizations build small internal centers of excellence around R, where a few team members become champions and help upskill others. Pairing theory with practice, as we do here, accelerates adoption.
Summing up, R is a powerful, specialized tool designed with statistics at its heart. Its strength lies in rich statistical methods, visualization, and reproducibility, deeply rooted in academic and practical frameworks.
And practically speaking, R drives value across industries, from healthcare to retail to automotive, by turning complex data into clear, actionable insights. Knowing when and how to use R is a key skill for data-literate business leaders.
So the key takeaway, if your work demands robust statistical analysis and compelling data storytelling, R is a tool you want in your toolbox.
And for me, don't shy away from R just because it looks different. Its depth and community support mean you can tackle tough data problems with confidence.
Next time, we'll dive into Data Tools SQL, the language that helps you talk directly to your data storage and unlock powerful querying capabilities.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your questions or comments. You might even be featured in a future episode.
Until tomorrow, stay curious, stay data-driven.